Hello, Algebra. I am sure you are as excited as this guy because we are almost done. Almost done with our course this year. And as we go, we need some terminology for this next unit. So we are going to learn about simplifying radicals, but we need to know what a radical is. So we read this symbol as square root or radical. So this is the square root of 9 or the radical of 9, and 9 is called the radicand. We're not really going to use that word too much, but I might say it every once in a while. So that's the number underneath the radical symbol. The square root of 9 is an example of a perfect square, and every positive radical expression has 2 roots, okay? 2 roots. It has a positive root and a negative root, positive and a negative root. So let's chat. All right. It's important that you understand and that you have this chart. This chart's going to help you a lot with knowing which are the perfect squares. So if I square 1 times 1, it's like the undoing of the square root. So square root undoes squaring, okay? Square roots undoes squaring. So 2 squared is 4, right? So the square root of 4 would be 2. So like I said, the square root undoes what we have, the number that we have squared. So write that down. Pause the video to do so. Make sure you know what you're talking about. And then we're going to talk about this property. This property says that if I have a times b multiplied underneath the radical symbol, I can rewrite it as the first number times the second number underneath square root symbols as well. And why is that important? Because we're going to learn, how to go from multiplying. We're going to learn 2 methods of how to simplify our radicals. That's why it's important. Okay, so let's look at this first one. This one helps us know. Did I change screens? No. I just moved down. Okay, just making sure I'm on the right place. Okay, so we're going to look at applying this property. So this says the square root of 4 times the square root of 25. We have 2 different ways that we can do this. We can simplify both of these, especially since, I don't know if you noticed, but they're both on that chart. They're both on the chart above. So one way to do this is if I notice that they're perfect squares, I can just simplify them and then multiply those numbers. The square root of 4, according to our chart, is 2. The square root of 25, according to our chart, is 5. And what's 2 times 5? Well, it's 10. Okay, fantastic. Now, let's look at method 2. Method 2 says that I can multiply these together. And if I do that, I would get 4 times 25 underneath my radical symbol, which would be the square root of 100. Well, look on our chart. What's the square root of 100? Well, it's 10. So either way, we have gotten the same answer. So sometimes it's going to be easier to do this method, and sometimes it'll be easier to do this method. Sometimes our number is going to be set up like this already, and then I just follow this method. So you decide which method works best for you, and we'll go from there. We're going to do number 2 in class. So we'll come back to that one. Let's talk about this, standard form. So I want to write all of my radicals in standard form. You want to look at your number, and you want to look for the largest perfect square. okay? I'm going to show you how to do this in two methods, but one of the fastest way to do it is to look for the largest perfect square and take that out. So if I look at my perfect squares, in method one, I'm going to use this method. If I look at my perfect square chart from page 1, what is my largest perfect square that I can divide 50 by evenly? Well, it's 25. So this is the same thing as the square root of 25 times the square root of 2, right? Right. Okay. So what is the square root of 25? Well, it is equal to 5, just 5, times the square root of 2. Can't get any smaller, so this here is my answer. So when you do this, that took only one step, and then simplifying that, so 2 steps. There is another method to do this. It's called a factor tree. And so when you do your factor tree, you are looking for the numbers that multiply or that divide 50 that are prime. So the prime numbers are numbers that can only be divided by themselves and 1. So 1, 3, 5, 7, 11, those kinds of numbers. Okay? So I like to put the smallest prime number out here and then whatever it multiplies to out here. So if you look at 50, 50 can multiply, can I divide 50 by anything? Sure, I can divide it by 5. And then I'd have a 10 left over, right? Both of these would be underneath. All right, so then the square root of 10, I can't simplify this anymore, but I can simplify the square root of 10 to the square root of 5 times the square root of 2, right? Okay, now here's the thing. Anytime I have 2 of the same number under my radical, because this is the same thing as this radical of 5 times 5 times 2. Okay, so that's what we did here. In our factor tree, we figured out what all the numbers were multiplied together that equal 50. You don't have to write this part. I was just showing you that. Okay, but anytime you've got 2 of the exact same number, that number comes out of the radical. So it's kind of like shoes. Okay, so you can think of this method is, do I have a pair of shoes? In other words, do I have 2 shoes? Well, these shoes would be size 5. Okay? If I have a pair of shoes, I can go outside the house. Do I have a second size 2 shoe? I don't. So this guy is stuck under the bed. Its partner is somewhere else. So this pair of shoes is a pair of shoes you can't wear. So, but you could go outside of the house like this. If we think of this radical symbol as a house, and then, can I leave the house with my pair of shoes? Yes. Okay, so what size is my shoes? It's size 5, and this little size 2 pair of shoes is stuck inside because it doesn't have a partner. So it stays inside and the 5 comes outside. So there are 2 different methods that you can do this. Look for your perfect square. And then what is it multiplied by to get to our number? And then undo our perfect square and simplify. Or do a factor tree and look for pairs of shoes. Okay? Those are your 2 methods. We will do number 4 in class. One more I'd like to do the square root of 200. Okay? So if I do the square root of 200, what do I get? Well, what's the largest perfect square that I can find in there? Well, it's 100, right? 100 times 2. So I'm going to use that perfect square method for this. What's the square root of 100? It's 10. Can the square root of 2 come out? It doesn't have a partner, so that's my answer. Okay? What about 162? Let's do 162 using that factor tree method. Okay, can I divide 162 by 2? I sure can, and I'm going to get 81. Can I divide 81 by a number? I sure can. It's okay if you don't write these underneath the radical. 81, I can divide 81 by 3, and that's 27. Can I divide 27 by 2? No. Can I divide it by 3? Yes. It would be 3 times 9, and then 9 is 3 times 3. So now we need to go through and we need to look at how many pairs of 3s I have. Well, I have a pair here, so one pair of shoes size 3 can come out. I have a pair here, another size 3 shoes can come out, and then this guy's left under the bed. So 3 can come out because of this, another 3 can come out because of this, and then I have my square root of 2 that's left underneath because there isn't a pair. Now I want to go one step further and simplify this, and I get 9 times the square root of 2, and that's my answer. We'll do 12 in class and go from there. I want to talk about 8. Okay, number 8. So this is applying that rule that we learned, or that property. The square root of 3 times the square root of 2 is the square root of 6. Now I have to ask, do I have any perfect squares in there? Do I have any pairs of shoes in there? I don't. This is my answer, so I'm all done. Okay? So now, what about something like this? Here, if I'm going to multiply, I'm going to do what I did in times past. I'm going to multiply this times this, okay? And then I'm going to multiply my radical times my radical. And here I'm going to get 8, and here I'm going to get 15. And that's my answer, okay? We'll talk more about 10 when we get to class, but I do want to look at 11. 11, maybe. Okay, my screen won't advance, so I guess we'll go over 11 in class. So, God bless. Come with questions.